Okay, so let's take a look at 2018 number 6. Okay, so consider the differential equation dy dx equals 1/3 x times y minus 2 squared. A slope field for the given differential equation is shown below. We need to sketch the solution curve that passes through the point 0, 2, and sketch the solution curve that passes through the point 1, 0. Now, I can't imagine they'll give you anything like this on your AP exam this year because it is online, but just kind of reviewing this skill. This was the last thing we did before we left on our extended spring break, so I think it's good just to kind of refresh and take a look back at it. So for the point 0, 2, they already have that point labeled there, but we need to follow the slope field through that point. And the curve must go through the point that's there and follow the given slope fields and extend to the boundary of the slope field. So it must fill in the entire graph all the way through from edge to edge. So for the point 0, 2, which is located here, we're just going to draw a line that follows the slope field, and this one looks pretty easy because it looks like it's just a horizontal line. Okay. We also need to do the same thing with the point 1, 0, 1, 0 being already labeled. And what we're going to do is we're going to follow the slope field through that point and extend it all the way through from side to side. Okay, so I'm going to start on the right side and kind of follow it back through. It looks like if I go through this point, it needs to have that kind of slope. And it doesn't need to go through the tick marks, each and every single tick mark, but it should be really close to it. Notice how here I'm pretty parallel to it. Here I'm pretty parallel to it. I'm pretty parallel to those slopes that are there. I'm not necessarily going through each and every single one of them, but I'm still following the general idea of the slope curve, of the slope field. So if I continue this, it looks like it may do something like this, and it's going to continue through, and it's going to continue all the way through to the other edge. Okay, so whether you go through some of them, none of them, all of them, just it should follow the general shape of that slope field. Okay, all right. Part B, let y equal f of x be the particular solution to the given differential equation with the initial condition f of 1 equals 0. Write an equation for the line tangent to the graph of y equals f of x at x equals 1. Use your equation to approximate f of 0.7. Okay, so it looks like we have an initial condition. We need to write the equation for the line tangent of y equals f of x at x equals 1. So let's go ahead and do that first. Okay, so a tangent line. Remember what a tangent line is? A tangent line is y minus the y coordinate equals the slope times x minus the x coordinate. So in order to write that equation, I need a point and I need a slope. And it says that x equals 1. I need to write the equation at x equals 1. And it also tells me that I have that initial condition of f of 1 equaling 0. So I have my x, I have my y, but I need a slope. Okay, so the slope is what was given at the beginning of the problem. This is my slope of the function. That is the slope of y. That's the derivative of y. So the derivative is your slope. So what we need to do is we need to plug in this point. Okay, so x is 1, y is 0. We're going to plug them into the slope. So we have dy over dx at the point 1, 0 would be 1/3 times 1 times 0 minus 2 squared. Okay, the derivative was given at the top of the page, so rather than scrolling back up for it, it's 1/3 x times y minus 2 squared. So we're just plugging in the 1 for x and the 0 in for y. Simplifying this, we would get 4/3. Okay, so the slope is 4/3. So let's go ahead and plug these in to write the equation. Y minus 0 equals 4/3 times x minus 1. All right, so that's your tangent line. And what it says to do next is use your equation to approximate f of 0.7. So we're going to take 0.7 and plug it in for x. So y equals 4/3 times 0.7 minus 1. 0.7 minus 1 is negative 0.3. Negative 0.3 times 4/3. Simplifying this, let's see. You got a couple different choices here. You could multiply. I would multiply it just straight across, actually. Negative 1.2 over 3, which would be negative 0.4. Okay? I was thinking maybe you can move the decimal over, but honestly, I think it's just easiest just to multiply straight across and then divide. Okay, so negative 0.4 would be my decimal approximation. You would get 1 point for your tangent line and then 1 point for your approximation here. If we went back to part A and talked about the points there, 1 point for each of these as long as they went all the way through the graph and followed the slope field. Okay. Part C, find the particular solution to y equals f of x to the given differential equation with the initial condition f of 1 is equal to 0. All right, so let's see. We've got dy dx. I'm going to pull up this. Dy over dx equals 1/3 x times y minus 2 squared. The first thing we need to do is we need to get, in order to solve this, we need to use a separation of variables. Okay, so everything with an x needs to move to one side and everything with a y will need to move to the other side. So the 1/3 x would stay and the dx would come over here with it. I would divide by the y minus 2 squared and the dy would stay. Okay. My next step would be to get rid of the dy and the dx. And the way that we get rid of those is using an integral. So we're going to take the integral on both sides. Now, because these are both equations, what we're going to do is we need to figure out their antiderivatives. Okay. The x one's pretty easy because we just add 1 to the power and then divide by the new power, but we'll multiply it by the 1/3. And we are going to put this plus c on that side with the x. So this side would equal 1/6 x squared plus c. Now the other side's maybe a little bit more difficult because we have this y minus 2 squared, but that shouldn't confuse you. Let's kind of do this one off to the side just to kind of look at it individually. 1 over y minus 2 squared dy. If it helps you, let's do a u substitution. Let's let u equal y minus 2. Okay, so now what I have is just 1 over u squared. Maybe that makes it a little bit easier because then we don't have this y minus 2 going on. And what I can do is take the derivative on both sides. So du equals dy, and so that dy will just change into du. And what I can do is I could rewrite it as u to the negative 2 du, and now I've just got a regular power. I can add 1 to the power and divide by the new power. And I'd have the plus c there. And then putting the u back in, negative y minus 2 to the negative 1 plus c. And then I would move that to the bottom, negative 1 over y minus 2. Okay? So that integral would equal negative 1 over y minus 2. Negative 1 over y minus 2 equals 1/6 x squared plus c. Okay, so we're going to solve this for y. We want to get the y by itself. So what I'm going to do is I'm going to multiply both sides by y minus 2. And then I'm going to divide by the 1/6 x squared plus c. And that would equal y minus 2. And then what I can do is Add the 2 to the other side. Oops. Put the plus 2 out in front. It doesn't matter where it's at. And then what I need to do is I need to use the initial condition. And that initial condition was that f of 1 is equal to 0. So when x is 1, y is 0. So I need to solve this equation now for c. And you could have done this step anywhere along the problem, anywhere in the problem starting, after you found your antiderivatives. You could have done it at any line. Just kind of depends on which one you think would be easier. I kind of wait until I get the y by itself and then plug it in, but it's up to you. So negative 1 over 1/6 plus c. I would subtract the 2 over, multiply by 1/6 plus c. Distribute the negative 2. So negative 1/3 plus negative 2c. Add the 1/3 to the other side, so negative 2/3. And then divide by negative 2. Remember, dividing by negative 2 is the same as multiplying by negative 1/2. And it's going to be positive, so 1/3 is equal to c. So what I would end up with is I would go back to this equation and plug in my c value of 1/3. So 2 plus negative 1, 1/6 x squared plus 1/3. Okay? All right, so this would be the answer. Although it's not the prettiest of answers, it would still work, and you could rearrange it a little bit, get rid of the fractions on fractions, but for the sake of the AP exam, you're good there. You don't need to simplify that any further. You've got the right answers. Everything checks out. You did all the steps. Some things to keep in mind when working through this type of problem. You need to make sure that you separate your variables. You need to find the antiderivatives correctly. You need to make sure you have your constant of integration and your initial condition. You use those. And you have to make sure you solve it for y. If you don't separate your variables, you will get 0 points on this one. If you don't have a constant of integration, the most you could get would be half. In this case, it'd be 3 out of 5. The point breakdown for this one is 1 point for your separation of variables, 2 points for your antiderivatives. They're going to count that together. It's an all or nothing type thing. 1 point for your constant of variation, or constant of integration, and your initial condition. So the initial condition is down here. Even though they're in 2 different steps, it's still going to count as 1 point, and then 1 point of solving for y. So your total of 9 points on your free response. Okay? All right, let me know if you have any questions.